All right, everybody. Welcome to the July edition of the Java User Group. Jonathan couldn't make it this week. He's doing a New York vacation with his family, so he's got his kids, and they're all running down the stairs of the library, something like that. We have a mailing list, so if you're not on that, you should sign up. We announce meetings every month and tell you what's coming up. We have a Google Plus community where a bunch of news and interesting stuff gets posted, and we've got a meetup.com group, which is, I think, a source of a lot of new people we've had lately. It's really good. Meetings get posted there as well. And we record all of these meetings, so you can go to our site, tjug.ca/videos, and you can watch them. And we also upload slides to our website as well. We get slides from the presenter and put those up. So if there's links and slides and things like that, you could easily get to those. So some Java news this month. There's some interesting stuff. The Java magazine, which is published by Oracle, talking about new and exciting things that people are doing with Java, has just released the July-August issue, so you can go get that. It's actually a pretty good read, surprisingly. It's worth. It's not as dry as it sounds. It's worth downloading it and checking it out and take a look through it. It's a pretty good publication, actually. There is a call for votes to start a project about a new version of JavaDoc. So there's an interest in making it all HTML5, to provide search features, to use the latest Doclet API, just generally enhance it. So if you're a heavy JavaDoc user, you may want to look at that. It's on one of the OpenJDK mailing lists. So it should be nice. The new Java 8 generated JavaDoc is actually quite pretty. I don't know. We'll see what they're proposing there. There's a new Oracle CPU, which is, of course, a critical patch update, which they release every couple months. So there's a new Java with a whole bunch of security fixes, and no matter what version you're running, there's a new one, unless you're running less than 5, and that would be really crazy and ridiculous, and I hope you're not. So definitely check that out. I don't know if any of you have been following Project Jigsaw, but that's a project to repackage the Java runtime to be more available on smaller platforms. And it's been going on for about 4 years now, something like that. And it's been in all sorts of various stages and stopped and started. And so they're going to try it again, especially with these new small platforms that are coming out, like Raspberry Pi and things like that. They think this is worthwhile. So these are the new goals of the project. Make the platform easily scalable, improve the ability to do minor security patches, so patch one part of the runtime, one part of the API. To make it start up faster, that was a huge part of the original Jigsaw, is to reduce the amount of loading that happens up front and makes apps start instantly, so it feels more like C. And just help with application deployment and packaging libraries together and providing. One of the big things was getting rid of the class path. So the whole class path concept was being removed in favor of better automatic searching and things like that. So maybe even a Maven-style dependency thing built into Java. So that's interesting if you're into that. It's worth checking out Jigsaw. Java calendar events is still here and updated as usual. And that's about all I had for this month. So anybody else with some Java news or anything interesting? New releases of software that you're working on, or fun new stuff in your favorite open source projects?
I'm interested in learning Scala.
Okay.
I just wondered if there's anyone else who's using Scala.
Anybody else here Scala people?
We're doing a bit of play with Scala at my company. There actually is a Scala version. They meet every couple months. They're on meetup. There's also a play for so there is quite a bit there right now.
That's right, yeah. All right, any other news? Okay, well, Adib has offered to do a nice talk today on Spring Boot and microservice architecture, so I'm going to hand it over to him and get to learn about that.
All right, so welcome. Thanks for being here on a very nice weather day. It's July and it's not, 150% humidity and a cool, super hot. So what I have planned for you today is like kind of two things. One is first explaining what the idea of microservices are. Who's heard of microservices before today? Who's wondering what all the hoopla is all about? Right, exactly. So first we're going to talk about the idea, and then we're going to look at how to actually build up some microservices. And we'll do a little bit of live coding and learn Spring Boot. So when you look at current applications that you work on right now, they tend to be big. Big in the sense of you have one giant WAR file, you deploy one giant EJB. Who says yeah? Like how many lines? Who says? How much? 300 meg WAR file. Anybody can beat that. Anybody got a 100 meg WAR file? Anybody got a 50 meg? All right. So the advantage of having this one giant thing is everything is in the same location, right? And that's how we've done things over time. So the microservices, when we look at current apps, we see that usually they have big budgets, especially for enterprises. Frequently big delays. Who's got long release cycles? Anybody here? The apps you work on might go every year or 2 years, a couple of weeks. That's pretty good. Hey, Christian, you guys. And all right, we just had a bunch of people walk in. I'll let you guys find a seat. Sorry. All right, so it tends to be the fate of enterprise applications that they are gold-plated with a lot of useless features. Who uses a web app that has features you don't care about? Who thinks their web app has features that nobody ever uses? Exactly, right? Who says it's relatively expensive to change? Like you have backlog items that says, we would really like to change the app to do this, but that would require a rewrite. Or would be 6 months and marketing wants it, but you can't deliver it. Anybody having any difficulty with scaling any of these large apps or had difficulty in the past? Those are some of the things that happen. And you also, unfortunately, get very slow payback for your return on investment. So if you have to work for 6 months before you release something and it starts making you money or earning you money, it's not going to be as nice as if you have something that you can put in production in like 3 weeks and start making money or saving money with it. It can also be a drag on business model innovation, because if you want to rapidly release things to react to your competitors, but your development process is too slow, it hurts you. And if you're working for the traditional enterprise type shop, you'll discover that there's a natural source of friction between IT and the business. Anybody experience that firsthand? Business wants things, IT says no, or the business sometimes, unfortunately, doesn't trust IT, so they'll go out and hire a vendor without telling the IT department, and then they find out and there's a big political fight. I've seen that happen before. And of course, what's the biggest problem with a large code base? Who says it's hard to understand a large code base, right? So that's probably for us the worst thing about large code bases. They're hard to understand. So what have we tried in the past? We've tried to have better processes to get better requirements, better development methodologies, better testing methodologies, better DevOps. Who's tried all those things? Yeah, or seen people do them, right? We've also tried better tools, like we tried better new programming languages. My favorite code about programming languages goes something like, the next programming language you fall in love with is better. Like programming languages are like girlfriends. The new programming language looks great, not because it's a nicer, better language, because you're a better person out of your previous relationship. So the new programming language looks great because you're a better developer out of the effort you spent learning the previous language. Some famous person said that, and I'm just badly copying it. All right. So how can we fix this problem? One thing we could do is, instead of building large app, what if we built smaller apps? So instead of building feature A, B, and C all bundled as one application with one giant database, what if we broke it up into 3 separate apps? And whereby each one of those apps is significantly smaller. So the idea behind microservices is that each microservice has its own database, it has its own business logic, it may even potentially have its own user interface, but it doesn't need to. Okay? The services could just be back-end data services. And what ends up happening if you do this is that you gain a lot of advantages, and there are obviously going to be disadvantages, so we'll talk about both. So who's clear on the basic idea? We just want to take a big app and deliver it as separate ones. What I mean deliver it, I mean like separate WAR files. In fact, there's nothing in the microservices that says write everything in Java. You could have service A in Node.js, or service B in Ruby, service C in Scala, service D in Java, service E in C++, to your heart's content. Whatever is the best language for what that service is trying to accomplish is going to be a good thing to use for that. So that's the basic idea with that. So anybody got any comments, questions about this? All right, what are some of the benefits of this? Well, it's going to be a lot smaller budget to build a microservice, right? Ideally, microservices were pioneered, I think, by Amazon and Netflix and some of those kind of small mom-and-pop companies out there. And they have, I think Amazon had a rule called a microservice could only be built by like a 2-pizza team. Anybody heard of that? It means your team can only be large enough that you take 2 pizzas to feed it. If your team would require more than 2 pizzas, it was too big. But depends on how much they eat and how large the pizza is. But you get the idea, right? So, so if we make it smaller, we're going to have a smaller budget. We're going to hopefully have smaller delays and shorter release cycles. It forces you to focus on the minimum marketable features for the thing that you're trying to release. You're not working against a long cycle. So these are all benefits just generally of agile development too. It's actually sometimes with microservices, the concept is it's sufficiently small that it's okay to rewrite it. If you're just not happy with it, maybe it's 10,000 lines of code. So a couple of people take 2 months out and rewrite it, or maybe 3 weeks and rewrite it in a better framework in a new language. It's a lot easier to scale. Now imagine if you have an application that was monolithic and you needed, like, let's say it was order processing and it's Christmas time and you're expecting a lot of people to use your application, or maybe it's a financial app and you're selling mutual funds and it's RRSP deadline and tax season. So during those times you need to scale it to scale up more. If you have a monolithic app, you're forced to scale everything up. If you have a microservices, it might be that certain microservices at certain times of the year need to be scaled up, and at other times it could be like spun down. So your number of servers that are handling your RRSP mutual fund sales, you spin up more of them from January to March, and then in July and August you spin them down. So you get much better usage of your infrastructure if you could deploy your large application as a bunch of small services. Of course, you put things into production faster, which means hopefully you make money faster and you save money faster. It's also much easier if you have a bunch of microservices to say, well, let's say maybe make a mobile app that talks to these 5 different microservices. When you change one microservice, you don't have to retest everything. Who's afraid to change their app because of the testing involved? Right. One individual microservice, much easier to test that than to test the whole thing. Hopefully this will build more trust between IT and business because you'll be able to deliver things faster to them and cheaper. And of course, my favorite thing, it's a lot easier to understand a 10,000 line piece of code than a 1,000,000 line piece of code. The problem is much more constrained. So if you actually look at what Martin Fowler says, and of course, nothing is real in our industry until Martin Fowler writes an article, right? Who's with me on that? He's finally spoken. He's published an article in March of this year about microservices. So I'm not going to go through all of these points, but kind of just to say the highlights of it is you're organizing the microservices around business capabilities. So for example, if we are speaking about, let's say you want to make an auction website like eBay, then you might have a microservice that only handles customer profiles. You might have another microservice that handles payments, another microservice that handles notifying people that they've been outbid, another microservice that handles the actual auctioning, another microservice. So you think of the business features that an application does, and that's how you slice by microservices. You're not slicing by layers. We're all trained to think of our application as data access layer, business logic layer, presentation layer. That still exists, but you have it within much smaller silos. So each microservice will have its own data access layer, business logic, presentation layer, whatever is needed. So we're going to split up the world into a lot of these microservices. Does anybody see a problem with that? Yes, what's the problem, Dan?
Lots of integration points.
Lots of integration points. Anybody else? Any other problems? Sorry?
Concurrency warring at the UI.
Concurrency warring at the UI level? I don't understand what you're saying, and I don't agree with you. Sorry. What I mean is this. If you look, okay, let me rephrase it this way. I'm thinking just of web apps for now, okay? Don't worry about desktop apps for a second. If you think of just web apps, modern web apps that are built on HTML5 and Ajax are fundamentally asynchronous, right? So they're all used to, I make a call and I wait for something to come back. So I think the concurrency there is kind of built into the mindset of HTML5 development. If you are talking about a desktop app, then microservices there aren't going to be that useful. This is really, I guess I should have clarified more about independently deployed running kind of back-end pieces of software. Am I making sense? Or yeah?
Are you going to get into how you deploy all this? Like, do you use like Beanstalk or are you going to get into that?
Yeah, I'll get into that. Okay. Yeah, I'll get into how to actually deploy. Yeah.
Well, how small is too small? That's the problem that I see.
Good point. How small is too small? I have no clue.
Let's say I have a bunch of apps and they all deal with like the concept of a department.
Mm-hmm. So
Deal
you.
with it differently. How can I make my microservice? Do I have different microservices that deal with departments? Do I have one microservice that deals with departments?
The question is, what if I have a bunch of services that deal with departments? Do I have one microservice that does departments for all the other microservices? That would be the natural thing because you're trying to get one source of truth potentially. So if you can make one and it makes sense within your business logic and business processes, go for it. If it doesn't make sense, be flexible, right? There isn't really this is described as an architectural style rather than, you shall do it this way. Is anybody being reminded of SOA? Service-oriented architecture, WSDL, SOAP. No, nobody is old enough for that. No one does that because it's over-engineered. Yay. Okay, and this is different because what we're talking about here is that we want to take our microservices, we want to deploy them into production rapidly, like within 2 months. You're not going to sit there and spend 6 years at $500 million engineering a SOA architecture for a bank, for example. This is like put stuff into production right away. So what are the tools for building microservices? You're going to need some sort of scriptable cloud infrastructure to automate the continuous delivery pipeline. So you can't really do microservices if you're not able to push code into production reliably without human intervention. Because your system might now have 65, maybe 100 separate individual deployable services. And if those individual deployable services are, like one of them goes down, you want to know that. You're going to need a lot more rigorous monitoring. Who can see that? A lot more rigorous metrics, right? You're going to need a lot of things that you normally can get away without doing in a large monolithic app. A lot more automation. You're probably also going to need some sort of reliable messaging infrastructure. Something like, RabbitMQ, WebSphere ActiveMQ, JMS. Something to basically be able to fire an event and know reliably that that message will make it to some location. You also probably want to use a fairly lightweight framework. You don't want something with high ceremony because if you're going to put something out into production in 8 weeks, you don't want to be spending the first 2 weeks configuring and setting it up, right? If you're going to be building a project that you're going to be working on for 6 months, maybe spending 2 weeks at the beginning to configure and set it up is okay. But all of the effort around like how fast can you take a server that's blank and spin up all the infrastructure you need to deploy the microservice becomes very, very relevant. So if you're like using things like heavyweight servers, I don't know, WebSphere, WebLogic, those kinds of things that require very long installation procedures, very intricate configurations, they're not exactly the nicest things in the world to do microservices on. You'll see that I'm a proponent of main methods. No, nothing. You just write a main method and you spin up your Java microservice. So you want some highly productive development framework and containerless runtimes so that life is easy because the clouds understand processes, they don't understand containers. So let's talk a little bit about Spring Boot and get to some actual coding. So Spring Boot makes it quite easy to create Java applications that just run. It's inside of Spring Boot. It can either use embedded Tomcat or embedded Jetty, your choice, which one you want. And it automatically configures all of the infrastructure. So it makes the task of standing up a server trivial. In fact, we're going to write a whole application in the next 45 minutes that will talk to a database. It will have a REST endpoint. And if we have enough time, I'll push it to the cloud. And you can visit it from your iPhones and stuff like that. And it has a lot of production-ready features, such as metrics, health checks, externalized configurations, all that other stuff. So let's actually get to the coding. All right, you guys.
Oh, what's that second tab you have up there? Adib, what's that? Oh.
I'll tell you about it another time. I've been obsessively building a little cloud in a backpack.
Oh my God.
So.
What a nerd.
That's okay. My shirt says that.
Yeah, it does actually.
No, that's a terrible theme. I actually have to switch back to my. Yeah, that's I was trying it, but trust me, it's not properly configured.
It takes a while to get all the settings.
Yeah, to get all the snags worked out. Some colors are all wrong. So we're going to use this guy here. So I just want to get all the other things out of the way. And so we're going to start out, and I'm going to build this Spring Boot project, and create a Java project. No, I'm going to create a Maven project. So file. Apparently doesn't work very well if you're drinking beer, the mouse pad. So we'll do Maven. So create a simple project here. So we're going to call it com.example.tjug. And we'll call it demo. And then, it's a jar finish. OK. And I should probably add it to this thing here. Did I just call it demo, right? Yeah, this is Eclipse failing me as usual. So we'll try this. If this doesn't work, we'll switch to Spring Tool Suite, which will work. Will not fail me. All right, we switched to Spring Tool Suite. There we go. So we will.
It's like a secret place.
This looks surprisingly like Eclipse.
It is Eclipse. It's just a little bit more working for me here. So yeah. This one is edit. Which working set do I have active? Oh, let's take CF introduction. Edit active working set. Remove. Finish. All right, so I do have a working one there that I will be copying and pasting things from, but we will go like this. So this one is more interesting because it has things like Maven project right there. Simple archetype, com.example.toronto. All right, jug. Eclipse is so funny. It's Eclipse does not wish to be my friend today, guys. Demo gods. Well, we'll do it the other way. I was wanting to do something for you purely from a wizard, like building it completely from scratch, but I'm going to use the wizard and cheat because I know that one works. The problem is Eclipse sucks and should not be should not be really used anymore by anyone. So. All right, so we're going to use this wizard here, and I'm going to start out, and the group is going to be com.example.tjug.
You started an IDE.
Yeah.
VI.
It's a simple pump. I'm sure you can eyeball it.
All right, if I can have your attention, please. Let's hope this one works. Third time lucky, all right? So we're just going to do that. Now, unfortunately, this is going to demand internet, and I keep forgetting to put it in the proper tjug demo. Let's finish. Apparently, yeah. It does work now. Except that this did a little bit more than I wanted. So I'm going to start by actually deleting a bunch of stuff. But yeah, it's going to make the demo take longer. All right, we'll just see what happens. Let's start out by the pom.xml that was generated. Is anybody having an eye test in the back? You guys good? Okay, cool. So what just happened here is we created a project, and notice that the parent of this project is the Spring Boot starter parent. And because this is how many people here understand what Maven POM files do? Okay, so what that means, because you're inheriting from that, you're getting the version numbers of about a few hundred different packages that are well tested with each other, right? Then the next thing we're doing is we're saying we would like the Spring Boot starter and the Spring Boot starter for testing. So if we just take a look right now at our Maven dependencies, you'll see that there is a variety of stuff. Spring Boot, bunch of Spring-related things. Log4j is there. Logback is there. And a bunch of other stuff for testing, like Hamcrest and Mockito and da-da-da-da-da. So Spring Boot is kind of a bit opinionated. It basically says, we think there's a right way to do things, so let's just start that way. So it gives you a bunch of pre-baked dependencies that are tested. So let's take a look at the application that's been generated for us here. Let me make the fonts a little bit bigger here. They'll be a little bit easier to follow. Let's try it.
Drink less.
Okay. All right, so hopefully you guys in the back can see that. So what's happened here is, first of all, what do you notice about this? Main method. Yay! Something I can launch. So let's actually see what happens if we run it. So I'm just going to run it as a regular Java app. And Eclipse doesn't know that my screen is smaller. Actually, nothing on the Mac knows when the screen gets resized. So what's happened here is that it started up, and it has amazing ASCII art that says Spring. You can be a hipster just like the Ruby people. And you can see that it actually ran to completion. It just ran and exited. It was a main method, right? It finished. Nothing really kind of interesting happened. Now, what's interesting about this is a few things. First, if you search this, the only XML is the pom.xml. There are no XMLs anywhere. So this one says add configuration. That's a standard annotation in Spring that says this piece of this code, this class, contains configuration information about the app. We're telling it to do a component scan. So Spring will automatically look for code under the package com.example.tjug. It says what package is the main class in. Oh yeah, all the sub-packages of that I should look at to see if they have code for the app, because that's probably what you would do, right, for your application code. And then it says enable auto configuration, which means, OK, take a look at the class path. And if you find something on the class path, auto configure it without asking me any questions. Just do it, please. So there was nothing here to auto configure, which is why it started up and shut down. So let's start adding some things to the class path and getting it to do more interesting things. So the way we do that is we just take one of these dependencies and we add more of them. So we'll take this and we say we want starter web. So when I say I want starter web, what's going to happen now is all of a sudden, if you look at my class path, look at that. I got Tomcat embedded. And I've got Jackson for REST endpoints. And I've got Spring Web and a bunch of other stuff. So what do you think will happen if I start up the app now? I'm going to have a web server. There we go. I've got a web server running on port 8080. So let's go to localhost 8080 and see what we find. White label error page. We didn't register anything. So, OK, well, let's actually add some stuff. How about we add some monitoring capabilities to our application before we write anything? Because we need monitoring, right? This app does so much stuff, we have to make sure it never crashes. But seriously, other stuff that you'll see here is it did launch Tomcat 7.0.54. There are ways for you to customize it, like set specific SSL certificates, change port numbers, all of that is available. But wow, I stood up a web server without downloading anything. How amazing is that? So I'll go here and I will add a couple of things. Let's add, because we need to monitor our application, I'm going to go here and add some more dependencies. But I don't remember the names of them off the top of my head, so I'm just going to copy and paste the stuff here. Let's add this guy right here. And so Spring Boot has this thing called the actuator. Let's see what it does. So all I did is, again, I added a dependency. And because I added that dependency, there are more things on my class path. And because there are more things on my class path, at startup, Spring Boot will find them and just automatically configure them. So let's see what kind of cool stuff we get with that.
So this is all because you did the enable auto config.
Yes. It's all happening because I enabled auto configuration right here. So now that this has started, whoa, look at that. There is a bunch of things that are now deployed, endpoints. So let's go to info. See, one of them it said was info. Oh, well, that doesn't do anything. No fun. Because we don't have anything defined. Let's try beans. Oh, look, these are some Spring Beans that are registered. Oh, that's one nice little JSON for you to consume. What about metrics? Let's see what kind of things if I go to metrics. Oh, wow, look at that. I can see how much memory the app has. I can see that the info page, /info, I've come to it once. It's received one request. Beans has received one request. And so if I go here to localhost 8080 info, again, that was the second request. So if I presumably refresh now, oh, look, It knows how many times my endpoint's been executed. Oh, how cool is that? I don't have to do anything. It just worked. Well, there's other stuff here. I think I can say threads. No, it doesn't do anything. Oh, dump. Yeah, right. Look at that. There's a thread dump as a JSON of your whole entire process. But all of this is not interesting or fun. I really like command line interfaces. Who likes command line interfaces? Well, let's try that. So let's add one more thing to this. Let's add the remote shell. So again, by adding the remote shell, what's happened is that I have more dependencies that are showing up on my Maven dependencies list, and I've got new capabilities for my Spring Boot environment. So what can I do now? Let's run the application and see what happens. Now it's going to print out a password. I'm going to need this password right here. This was auto-generated. And of course, I now have to do something with my shell. Can you guys see the bottom there? Yeah, so we'll do SSH-P2000 user at localhost. Yes, what's the password? I'll paste it. I just SSH into my application. Anybody like that? So what can I do? I can type help. What do you guys think I should execute? How about I try info again? Was there one? No, I don't want to send out any emails. We could try something like beans. Just prints out all the stuff. But my favorite one, because I really like, well, it doesn't have clear. Let's try dashboard.
You wrote this? That's amazing.
I didn't write this. This is kind of packaged and included with Spring Boot. So Spring Boot's philosophy is more like, you write a main method, you start depending on pre-known combinations of software by just saying, I want like the web, by saying I wanted web, like when I went here and I said, Spring Boot, please make this thing into a web application, I depended on the starter web, and that brought in all the dependencies to stand up a web server with REST and everything else I need. Okay? I added the remote shell, so it started up an SSH server. So who's liking what they see so far? Okay, cool.
Do you need the parent POM to do the autoconfig?
Well, you need the parent POM because the parent POM contains all the kind of pre-baked dependencies. Like we didn't specify which version of the starter actuator to use. It inherits all of that from the POM.
But if you spec your own actuator version and you didn't specify the parent, could you still do enable autoconfig?
You could if you went and included all of the individual, but then you would have a POM file that's like 1,000 lines long. So this is actually what you're getting with the parent POM is not only a bunch of common dependencies, like in dependency management, so you don't have to specify their version numbers. You're also getting a bunch of plugins, and you're getting Maven configured in the same way. So you don't have to go to the trouble of doing a same configuration of Maven. All right, so now that we got this, let's actually start adding some code. Who would like to add database access? All right, let's do that. So, all right, quiz for a beer. Who can tell me, how do I add a database access to this?
Starter database.
Starter database. He gets a beer. All right. Actually, you're not quite right. If we
Put that beer down.
okay, actually, it is correct. If you do start a database, it will ask for a data source. It will actually give you a database. But what do we really want? We want JPA, right? So let's do that. Okay, so let's actually take a look at this guy here. And let's say we would like Spring Data Starter JPA. So let's see what happens if we add it. So now I've added the data JPA, And what will happen now is it's going to drag in Hibernate. That's what just happened. And everything that you would need to configure Hibernate. Who's ever added Hibernate manually to a POM file? Who spent hours like kicking out all the dependencies and making things work? Right. So it just gave you a Hibernate that works. So what will happen now is, let's see what happens if I launch the application. Error message.
I knew it. I couldn't believe it was too good to be true.
It was too good to be true. But let's actually look at the error message. What is the error message? Oh no. It says, cannot determine embedded database. Oh, we never told it what kind of database we were going to talk to, right?
Too good to be true.
Well, we're configuring Hibernate, but we need to tell it what database. I mean, we have to do that.
It can't guess H2.
It can't guess what you want. But what I actually want is I want it to talk to a Postgres database. So what do you need to talk to a database? You need what kind of driver? JDBC driver, right? That wasn't worth a beer. That's like half beer, if you knew the answer to that. So what we need to do is let's go and drag the JDBC driver for Postgres and copy and paste it into our application here. So here we are adding the Postgres JDBC driver. Now let's start it again and see what it says. Still doesn't like it. Whoa, what are we doing wrong? Well, we never told it where the database is. What's the IP address, port number, hostname. So how do we do that? Well, it turns out that Spring Boot makes your life easy. You see in SRC main resources, there's a thing called application.properties. You just stick properties in there, and it just finds things. So what I'm going to do is, I'm going to just go here and just take that and copy and paste it here. So here I've just said Spring data source URL. Here's my JDBC URL, username, password, driver class. That makes sense? Now you could go in here and you say data source.min.max. All that stuff for connection pool. So you put all the settings there if you wish. And if you did do that, that works just fine. It is using underneath the JDBC connection pool from Tomcat, which is far better than DBCP. Much more highly for concurrency. Yeah. Okay, so the question is, what if you wanted to have two databases, right? Totally. What you do is you just put different prefixes in front of them. So you'd say like salesdb.datasource.url, and then salesdb.datasource username, and then you'd say that's Postgres, and then your ordersdb, let's say, is in MySQL, ordersdb. So you can have multiple data sources. The thing about Spring Boot is it wants to make it really easy for the most common case. Most common case, you have a single data source. If you have more than one data source, you go into the help file for Spring Boot, and it just explains to you how to do it. So if I go here, click on the Spring Boot reference, go to data source, and go through that section, it will show you how to do multiple data sources. In fact, I'll show you that a little bit later. Okay? So just trust me that it does it very, very nicely and easily. It's also incredibly well documented. Okay, so now that I've got that, what will happen if I start up the application? Hey, no more errors, right? So let's now see what's going on with the app. So let's go to info again. Well, info still doesn't say anything. I don't like it. It's not very informative. Let's go to health. So health tells us that the hello application is OK. The database is Postgres, and everything is good. So it tested my JDBC connection for me. Cool, eh? Who's finding this like really much easier? Like this is almost as easy as like Ruby and Node.js and all that stuff if you know Java. So let's do the next step here. And in the next step, what we want to do is we want to actually add some tables. Who'd like to add some tables to the database, right? So we could go and do it ourselves, but it's nicer to get a framework to do that, so I'm going to use Flyway. So how am I going to add tables to my database? Who knows? Some people here know Flyway. How do you guys think I'm going to do it? I'm just going to add another thing to the POM, right? Yeah, another dependency, exactly. So you can have a beer. So I'm going to go here, and I'm going to say I would like Flyway. OK, so there we go. Now, notice that I didn't have to specify the version number because it's coming from the Spring POM, from the parent. So it's giving me the latest one that works well with this version of the combination of packages. And the way that works is it looks, this is now Flyway. This is not Spring Boot. Flyway looks for a file, files under the package DB migration. So here I've just created a simple table called contacts with a serial, text, name, email, and I'm inserting one row, right? Everybody with me on this? Cool. So what do I do now is I will go and start up the application one more time. So we'll shut this down. The way that Flyway works is that each one of the files executes within one transaction. If you happen to have a database that does transactions on DDL, you're OK. If you're using a database that doesn't do transactions on DDL like Oracle, then you're doomed. It will not be able to roll back. So Flyway is a very nice system, and I totally love it. I did an earlier Jug talk on it, and it's on, I think, the Jugs link. You can watch the video. You can watch the video, that's right. So what will happen is just before I do that, I'm going to actually make sure my database is clean here. OK, this was just me dumping, cleaning out the database and destroying it, so that when my application runs, OK, so now what will happen, we should see something from Flyway. Or so I hope. OK, there we go. So you'll see here that I've got this table called schema version. So view all rows. That tells me that the script v1 create phone table has been executed. And I've got the contacts table that script created. Okay, so nothing really fancy, not very important. So what can I do now? Now I just need to define an entity to create it, to interact with it. So I'm just going to go here and create a new class. Let's call it contact. Well, I'm going to cheat in the interest of time, and I'm just going to copy and paste it from over here. You don't need to watch me type all that one in. So here's just a standard JPA entity mapped to the contacts table, ID, column, name, email, right? All that stuff. I guess this one doesn't have a generated value, so I'll just add that. All right, there we go. OK, so we've got that. Now we should probably, it'd be nice if we could get it from the database, right? So we need to create data access object, don't we? How shall we do that? OK, well, let's add one. I don't have one handy to copy and paste. So let's create a new class here, and let's call it the contact. So really hard to spell when you've had some beer. And this is going to extend the JPA CRUD. Now I don't remember the name of the class off the top of my head. Well, we will easily find that by browsing the class path for the Spring data. It takes the flow out of my presentations, but Spring embedded. For 1 beers, and you remember the name, the base class for the Spring data JPA repository.
There it is.
There we go. When in doubt, F4 to the rescue. Yeah, that's what we want. Okay, so we need this guy to be an interface. And we're going to extend from the JPA repository. And we're going to tell it that the data type is contact. And it is an integer, that's the primary key. And let's just tell it that this is a repository. Okay, now I should be able to no, this is fine. I just need to go here to application, actually I need to create some new code. Let's create a service that uses the repository. So let's make a class, call it the phone book service. So we'll say that's a service. And we're going to have a reference to the contacts repository. All right, so now what I'm going to do is, let's say we want to do list of contact. Let's do all. Return. And let's just put make it transactional here. Okay, for some stupid reason, no, not the JavaX transactional, please no. We want the Spring Framework transactional. So we'll say we want this one to be, all right, let's require, this is the default. I'm just putting it just to show you how it works. Now, one of the interesting things about the repository is, first of all, let's just look at the repository again. Wait, I didn't define a find method, right? So what's happening here is this is the Spring Data project that's being dragged in. And what the Spring Data project does is it looks at the interface, and it automatically generates an implementation of the interface using JPA. And I'll be able to add methods to it in a short while here and show you. But let's make sure that this one works. So we've got a service. Now we're going to need to add a controller. So let's just take this phone book service here, go like that. Okay, now this is, the layers here are kind of not doing that much, just to keep it simple. You know, you could imagine that you would actually have something here that does something real. So we'll just knock that out, change that to the, no, not the repository. Oh, it's a phone book service, right? Okay, cool. So if everything works, I should be able to, oh, I didn't bind this to a, so we'll do at request mapping. So now if I go to /, I shouldn't get white label error anymore. I should actually get a JSON with all the rows in the database. So let's test that out. Will it work the first time? I hope it does. White label error. What is going on here? Oh, null pointer exception. Get all. Oh, right. I forgot an annotation. I have to put at. I could put at inject, but I like at auto wired, so I'll just use that. So now I should start it up again, and I should actually see my app. I wish it worked the first time. Yeah, it never does. Usually takes 3 times. All right, what's the problem now? So you can see this is live coding. This is again, copy and paste error. This is the beer, man. That's why it's good to pair program. You guys aren't pair programming with me here. If you were pointing out my bugs, I'd have bought you beers for that. Oh, internal server error again. What could be the problem now? Oh, all right. I know the problem. Again, I'm not paying attention. So, so the default behavior is with Spring MVC is that it assumes that there was a view that was supposed to be processed. I didn't tell it that this was a REST controller, so I just need to tell it that this is actually a REST controller. Yep, could have had a beer. All right, let's try again one more time.
Oh, woo! Hey, wait. Put that in there.
I put that in there with the insert script. Yeah. All right, here, I'll prove it to you. How about we add you to it? Come on, we got to add you to it now. So we can go here, view all rows. Let's just add a row.
My name's Andrew.
All right, here. Cool, eh? So that, I think, was in, what, like 35 minutes or so? We managed to spin up an application. It has a, let's see, what can it do? What can you do with this application? Well, we can do quite a few things. So we can SSH into it. It has monitoring and health metrics. It's talking to a database. It's got an embedded server. And yeah. Well, if I add Spring Security to it, if I add Starter Security, it'll start demanding a username and password. So, but I'm not going to show that because that's when there's another thing I want to show that. I'll show you to you guys. Any questions or comments at this point?
For example,
Does it?
you start 2 services and talk through messaging.
Well, if you want, sorry, say that again.
You start 2 microservices, then they communicate through a certain messaging.
Well, if you start 2 separate microservices that need to talk to each other, you might need to have a message queue set up with the proper queues and stuff like that. So I want to actually demo to you next how you can push this into production. Who'd like to see this on the internet in like a few minutes? All right, let's do that. So to show you that on the internet, I'm going to need to use some sort of environment that I can deploy to. So I'm going to use Cloud Foundry. Anybody here heard of Cloud Foundry? It's an open source platform as a service. I'm going to use the public version called the Pivotal Web Services. So you can interact with it with a GUI, but I don't like GUIs, I like command line, okay? So I'm going to start off by going to CF apps. Now the way you interact with this thing is you use the command called CF, which is the Cloud Foundry command. And this will totally depend on the speed of the internet here. And this is not looking promising at all. So right now I have 2 apps up there. In fact, if you go to, I was going to remove a deep demo, but no, this one runs. You can go to it, it's talking to Postgre. I can show you the code for it. But we'll try to push this into the cloud. But in order to push it into the cloud, one of the things about the cloud is I can type, let's actually go to, where is that project? I need to go to the directory that has it. So properties, let's go here. Now the cool thing about Cloud Foundry is you can actually run it on site. You can run it within your own data center. So unlike other clouds where you like really enjoy using the cloud, but you're like, but I can't run it internally and they'll never let me run on Amazon. This one, you run it into your own data center, everything works. So we will, where are we now? We are in the right spot. Cool, okay. What do you mean by? You can download Cloud Foundry and you can install it in your data center, and then everything that I'm doing now, you could do against your own private data center. So the little project he was joking about was I'm actually going out there buying a bunch of little servers, like these Intel NUCs, and combining them to make a demo Cloud Foundry instance that I put in my backpack, my own private cluster.
Are you deploying a jar or WordFile?
Well, let's actually see how it works. Just give me that, okay? So first, let's actually ask, on the spirit of Spring Boot, let's actually ask Maven to package this. And by the way, I'm not going to talk at all about the testing that's built in. Build success, that's fine. I've got a jar file. That's all I need, right? So the thing that I want to show you here is that there are two jar files that got generated. You'll notice that one has the name .original and is only 5.7 kilobytes, which is what you would expect for an application with like 4 classes in it, right? But the other one is 33 megabytes. And what that contains, it contains all the dependencies inside of that jar. So now you've got one thing that you need to give to the cloud, one thing that you need to deploy to 1,000 servers. A lot easier to push that around, okay? So let's go here, and let's now do, okay, so what I'm going to do with a CF is the following, right? Okay, so I have to tell you a little bit about how Cloud Foundry works. So I'm going to type CF Marketplace. It helps to actually spell correctly. And I'll have to be a bit more of an eye test for you guys. We'll do that one more time. Okay, this looks like crap here, so we'll just go to... We'll go to the pretty version that will be easier for people to see. So on Cloud Foundry, you can have your apps up and running. I've created a space here called Deeb just to put my apps in, separate from the other stuff. This is used by internal people to play with. You can see I've got an app running here. And there's, very importantly, a marketplace in Cloud Foundry. And this marketplace allows you to go in and say you want a Postgres server. You click on, like, say, Elephant SQL, and it gives you what kind of plans are available. Like, Turtle is free, and Enormous Elephant is $499 a month. If you wanted, like, a Redis cluster or a too much here. This depends on the internet here, so can't promise you good results. So if you want like Cloud AMQP, Iron MQ, Memcached, Mongo Labs, New Relic, there's all these services. These are in the public cloud. Now, if you are running this privately, you would deploy your own services into it. Okay? So what I need to do in order to deploy an application is I need to bind a service to a okay, if we click on the space here, a space has a bunch of services and a bunch of apps. The services are accessible to all the applications that are built in. Just to save us time, because it's 7:54, I'm not going to go through the process of defining the services. I'm just going to go back here and type CF services. And that what you want to know is there's a service called data source, and it is an Elephant SQL. What is this? It's an Elephant SQL service. Turtle is plan, and it's bound to the application demo ID right now. So actually, I will, let's do CF stop. How to do this the easiest way. Don't worry about what I'm doing with this. I'm doing it because I don't want to break the one that's there right now, and I want to do all the steps. So I created a new space, CF target deep2. So the command line client that I'm working against, it knows which cloud it's talking to via the API endpoint. It knows which space within the cloud it's talking to. So now it's every time I type a command, it's going to work by default against that. If I type CF apps, this space, a deep2, has no apps in it. If I type CF services, it has no services. So I'm going to now type CF create service. And what do I need to specify? I need to specify the type of service that I'm creating, which is going to be Aleph. And I hope I know how to spell elephant without reading it. Tell me if I spelled it wrong. The plan I want is the turtle plan. And the service name is going to...
Not quite, not quite.
Not quite? It's going to be called data source. Okay. Did I spell turtle wrong still?
No, that's good. That's awesome.
Okay, so if I now type CF services, what's happened is that the platform as a service has provisioned a database for me, a Postgres database. Okay? Now, what I want to do is I want to push my application to it. And I need to do a couple of things in Spring Boot to do that. I need to configure the application to know to automatically read the data source that's defined. The way that Cloud Foundry works is that it doesn't care what language you push stuff in. So if I type CF build packs, don't worry about the space. I don't want to explain it right now. Sorry. Explain it after beers because I'm feeling pressured for time. So right now you can give this, you can give it Ruby, Node.js, Java, Go, Liberty, WebSphere, Liberty, Python, PHP will all run. You just give it the code and it does the right thing. So if you're going to have the same database be accessible from PHP and Java, you're not going to be going to define like a Tomcat data source or a WebSphere data source. What it does is when it launches a process, it passes an environment variable called vcap services with a JSON string inside of it with all the credentials you need to connect. So if you're a process in the past, you just read an environment variable, parse the JSON, and you know where to connect. And in order to make that happen, I need to add a couple of things to this thing. So I'm going to cheat and kind of go grab them from this guy right here. There's a project called Spring Cloud. So let's take the Cloud Foundry connector, the service connector. We'll take all of these guys here. And
I missed a bit of that.
yeah, I did. You're right. Okay.
So these are not managed by the parent.
They probably are, but I'm not going to test that theory right now. So what I've basically told it is I said, hey, Spring Cloud, I want you I want you to connect me to Cloud Foundry. Okay, so when this app starts up in Cloud Foundry, I want it to automatically be able to find data sources, mail servers, and that kind of stuff. So that's step one. Then the next thing I need to do is I need to actually configure a data source that's going to work in the cloud. And this is going to show you, OK, this is the local data source config. And let's take this cloud data source config and copy and paste it here. So now it's like when I'm running locally, I want to use my local Postgres server. So all I do is I specify a new configuration, and I specify that here's a bean. It returns a data source, go off and read the properties and create a database for me. So to answer your question earlier, if I wanted two databases, I put two of these things, and I put a different prefix, and I put their properties in the file. Now, in this case, I also wanted to get me a database on the cloud. So what I do is I create add configuration and say only run this configuration if I tell you that you're running in the cloud, to Spring. The way I tell Spring that I'm running in the cloud is I pass it a system property to do that. So I'm going to also steal this manifest file that I have here, tjug demo. And this manifest file is going to specify some information about the app. So I want to tell Cloud Foundry it's going to run on Adib2. The app is called Adib2-demo. It should take 1 gig. I'm giving it 1 gig. This is the URL I should reach it on. Adib2, well, let's call it tjug. Let's call this one tjug.cfapps.io. And I'm passing it an environment, like a system property, Java option to the JVM, saying Spring Profiles Active Cloud. So if the world is happy, then everything works. Let's see if this works here. So let's do ls target. Just make sure that we have, OK. So I'm going to now say cf push. Cf push is Cloud Foundry push. I'm going to push some code to Cloud Foundry. So cf push, the app name is going to be tjug demo.
Did you build the new jar?
Thank you. A beer, another beer. Thank you. Yes.
In an ambulance.
All right. So we built that. So we're going to now do cf push. And the app is going to be called tjug demo. And we need to tell it where the code is that we want to push. Otherwise, it pushes all the code in the current directory. So the path to the code is target, and it was called tjug, right? There we go. So it figures out that it's using the manifest, and it's going to now upload that 33 megabyte jar file from here to the Cloud Foundry. So I'll talk while it's doing that. So we'll see how long that takes. Anybody got any questions while it's uploading? The internet is fast here.
You told it to use a domain of tjug or something? What did you tell it?
No, I told it. So what I did is I told it upload the code in this jar file to Cloud Foundry, and call it. I want to call the app tjug demo. And what it did is it took that single jar file, sent it to Cloud Foundry. Cloud Foundry went and looked at it and said, "You just gave me a bunch of bits. What are those?" So it tested them out by running the Ruby build pack first. Says, "Does this look like Ruby code?" "No, it's not Ruby code. I can't do anything for you." Then the next build pack runs, which was the Java build pack. The Java build pack says, "What is this?" And it says, "Oh, that's a jar file. I know how to run a jar file. But before I run a jar file, what I need to do is I need to get you a JDK." So when you see it here where it says downloaded package 31 megs, it's not downloading anything. What's happened is that it is downloading it into like the staging environment in Cloud Foundry, which then went out and downloaded JDK 1.765, and then it combined the two things together and created a 62 megabyte droplet, which it stores in Cloud Foundry. But that 62 meg droplet has my application code plus the Java runtime plus all of the dependencies that are needed. So it can now take that droplet and send it to like 1,000 different machines. And it would run there without any kind of having to configure and install those Linux machines. Is everybody with me on that? I know I'm kind of going pretty fast. Any questions about that?
Where's your Postgres configuration?
Where is my Postgres configuration? Good question. I'll explain that. So let me get to that. So what happened after that is I told it there's only one instance of my app should be running, but it says 0 of 1 running, and it's like starting the app, and the app is down, and starting the app. And the reason why it's failing is because there's no Postgres hooked up to the app. We have to bind the Postgres service to the app. So I don't have to know the username, the URL, anything. All I have to do is type cfbs, which stands for bind service. So we'll do the long version of it. So cf bind service And what I want to do is what did I call my app? Oh, crap, I forgot the name. OK, CF apps. That seems to take longer than the other things. I don't know why. It's a TJAG demo, right?
Search in the cloud for your apps.
It could be anywhere.
All right, here we go. Let's actually stop it. So we're going to stop the TJAG demo. It's kind of flapping around, trying to start and not finding Postgres. So we'll tell it to stop. All right, now CF bind service. All right, CF bind service. The app name I'm binding to is tjug-demo. And the service I'm binding is the data source. So I'm now saying the data source should be made visible to the application called tjug-demo. Hit enter. And now I'm going to ignore what it says and do CF start. And CF start tjug-demo. We'll see if it doesn't work. I'll try CF push. So now it says 0 of 1 instances, 1 starting. Let's see if it works. Well, let's say we want to see the log files that are being generated. I can type cf logs tjug-demo. And that's going to stream the logs from the log aggregator. That's part of the thing, but it's not getting any logs right now. So we'll do -- recent. Looks like it worked. OK. So if I now type cf apps, I should see the URL that the application is running on. And everybody here should be able to go visit it. So it started on tjug.cfapps.io. So let's go to that. I'll just scale it up with more instances if you do that.
Can you scale up the Wi-Fi here? That's pretty cool.
So there you go, guys. So check it out. The data is in the database. Why is that? Because of the flyway thing that I put in, right? And so who would like me to scale the app, like run 5 more instances? Anybody? Well, Flyway will do that once. Okay, and it'll try to obtain a lock against the database. One of them will succeed. Yeah. Actually, let me put it this way. So remember the schema version thing here? So what Flyway will do is it'll look in this table, the schema version. It notices that it already ran that migration script, so it doesn't rerun it. Sorry? I can't hear you. I can't. You need to
add a column to my table.
Oh, so if you want to add a column to your table, what you would do is you would go here and you would create a new file, v2 __ update.sql, whatever. You give it a nice descriptive name, and then you do your author table, and then the next time it starts up, it's going to do that. There's also command lines. You could do it. You don't have to run it with the app. This is just convenient. So if I want to scale up the application in Cloud Foundry, I just say cf app. I think it's cf scale. So let's do that. Here you go. Cf scale. OK. So I say Cloud Foundry scale -i. How many instances would I like? Let's try 3. OK. No. No, I think it will reject 5,000 because it'll run out of space in the. Yeah. So when I tell it I want 4 instances, it's going to know that there's already 1 instance running, and it's just going to go and spin up 3 more. Okay. So if I now do cf apps, you can see it's already started 3 of 4. If I do cf apps again, see the apps takes longer. Now I've got 4 instances of this app running. Wow, was that easy?
So does it have a load balancer in front of it?
It has a load balancer. So Cloud Foundry has a load balancer, which when you deploy an app, you give the app a name. So let me answer that question properly. I'll use the web UI for this. So all of the apps that you're deploying, this is the public instance of Cloud Foundry. So all the apps run on the domain cfapps.io. So when I deploy an app, I give it a unique name, and it'll be that name.cfapps.io. If I deployed it privately in my company, like let's say my company is called ABC Inc. or abc.com, then I would pick the names to be like adib.abc.com. So each microservice that you're going to push, you give it a unique name. And it automatically detects it. The router that's built into Cloud Foundry receives all incoming requests and routes them to all the instances. It's also got a health monitor. So if one of the instances die, it'll automatically get restarted. And it's got an autoscaler, which you can configure in the private version, which will automatically, based on load, increase the number of instances, decrease the number of instances. So Cloud Foundry is worthy of its own talk. And there is a Cloud Foundry meetup group. So if you go to Cloud Foundry Toronto, I'll try to. Well, I'll tell you just in a second. So everybody here, make sure to go and register on the Cloud Foundry Toronto meetup. I'm a co-organizer on the meetup. That's my boss. He's very friendly, despite the picture. So our next meetup is going to probably be a workshop introduction to Cloud Foundry. Bring your laptop and play with it yourself. In terms of like if you go to run.pivotal.io, this is a public instance of Cloud Foundry that people can play with. You can sign up for free. And for 60 days, no credit card required. The pricing is 0.03 cents per hour, $35 a month for Beanstalk versus $10.80 for Pivotal Web Services. You guys can read the details on your own. The difference is you're probably wondering, like, where does it run? This Run Pivotal IO runs on EC2. Anybody kind of seeing, like, what the hell is going on? How can it be cheaper, right? Yeah. Well, the answer is, who knows what Linux containers are? Anybody know Linux containers? LXC? Okay. So when you run an instance of your app, it doesn't run it in a brand new virtual machine. It runs it inside of a Linux container. Linux containers allow you to have a very large VM that you then partition into smaller instances that boot up super fast. Really fascinating technology, but beyond the scope of this. I'm actually speaking at the Linux users group on August 12th on a technology called Bosch, which is used to deploy this stuff. So if you're into DevOps and system administration, come to that on August 12th.
What's the group?
The Greater Toronto Linux users groups.
Can you post this and that link of IO also on this meetup group?
Sure, absolutely. You can do that. This is the GTA log. I will be the speaker, as far as I know, unless they decided they don't like me. So, so this happens, it's at Ryerson. That's where they meet up. Okay. Right. Did I answer your question about, Mike, about the CF? So here's kind of my takeaway point. My takeaway point is the app server is dead. Okay? If your mental model of the world is I deploy code to WebLogic, to WebSphere, that is not scalable in the world of the cloud. In the world of the cloud, what you want to be able to do is deploy microservices that are written in the best programming language for the domain you're writing it in. So when you deploy to a platform as a service, your code, one microservice could be written in Go, another one could be written in Java, another one could be written in Ruby, right? The way that you locate services, like, for example, like Postgres. What I didn't show you is the fact that I can turn a service in there and register it so it becomes a microservice becomes a service in the marketplace for somebody else to use. So you could end up with like cascading things in there. I'd love to talk a lot about it, but I know I'm way over my time here. So I think that's pretty much it.
So microservice versus web service, what is your opinion?
Microservice versus web service. I think web service traditionally refers to a technology like SOAP and something available over the web. A microservice does not actually, it's more of a cultural thing. A microservice is a small piece of code It's independently deployed on something, and it's managed by a 2-person pizza team. You code it, you run it. It's not like you write the code as a developer, you give it to some poor guys in operations who are going to support it for the next 10 years. You look at the development budgets. An app might have let's say $1 million development budget, but then the app lives for 10 years. And over the next 10 years, you spend $5 million running the app because you keep upgrading the hardware, you keep buying expensive things to scale it and all that stuff. So this is, microservices are both, I think the larger part is they are a cultural shift in how you develop software. They go hand in hand with Agile, with DevOps, with those kinds of approaches. And the technology piece, I don't really care what it is. I showed you Spring Boot, but in the Java world, Spring Boot is cool because how easy it is to get going. But if you show that to Ruby people or Node people or Python people, they're going to be like, what are you showing me? I've been doing this for 10 years. Everything is easy to get started with. So.
Foundry, since your data persistent, if you have stuff in Amazon, it's not persistent. So how do you get data persistent?
The database that I connected to is not running in Cloud Foundry. It's a service external to Cloud Foundry. And you can run things in EC2 with block storage, and that is persistent. So I can answer that offline. Yeah. Anybody else? Any other?
Performance tuning the microservice. You see, for web service, I've used JMeter. But for performance tuning, how do you've been talking about scalability and things like that?
You tune it the same way you would tune any other web app. It's just that when you tune a web app that is 300 megabyte WAR file with 500 different URL endpoints, what do you tune? Do you tune one URL? Maybe the way you configure the garbage collector for one of those URLs is different than the way you would configure the garbage collector for another URL. Does that make sense? Maybe one URL is the one where somebody uploads to you a 300 meg XML file as batch input. Another one is where somebody's charging a credit card or looking up a transaction. So if anything, with microservices, in the design of the service, you can pick the right language, the right environment, the right memory sizing, the right everything for the type of problem that microservice is actually solving. Does that make sense?
Yeah. So you're talking about something like memory leak testing also.
No, I'm talking just generally how you size it, like how much memory you give it, how much CPU, all that stuff. Yeah. Okay. Great. Anybody else? All right. I think we're done. Thank you very much.